Okay, so tuloy natin yung pinag-uusapan natin last time. So last meeting, um, ang pinag-uusapan natin ay, or we started the discussion with Newton's laws of motion, and then nagbigay tayo ng isang example kung saan natin pwedeng gamitin yung Newton's laws. Yung example na yun was quite similar dun sa ginagawa nyo sa Physics 101. Okay, except na in this case, we used, sort of a new notation. Ang notation na ito is in the form of this, the dot, at saka double dot notation, which implies na pag may dot or may double dot, first derivative or second derivative with respect to time. And from that notation, we can sort of do some other things. Okay, like for example, derive itong equation for velocity. Okay, without using yung mga kinematic equations dun sa Physics 101. So, let's just continue yung discussion. Yung problem last time was about a block sliding down an inclined plane, okay, and walang friction yung box na yun with the surface. Dun sa next problem, meron na siyang friction. So we're going to introduce friction. If the coefficient of static friction between the block and the plane in the previous example is mu sub s equals 0.4, what angle theta will the block start sliding if it is initially at rest? Okay, so ang idea dito is parang yung experiment ninyo sa 101, di ba? Na ini-increase ninyo yung angle and you want to find out yung maximum angle until tawag dito yung block ay magsisimula ng mag-slide down. Okay, or yung angle just before the block starts to slide down. Kasi below that angle or from that angle and below that, doon dominant yung coefficient of static friction. Doon dominant yung static frictional force. Pero above that angle na over, mas malakas na yung gravitational force. So kaya niya nang i-overcome yung static frictional force at nagsislide down na yung block at nagiging at yung friction between the block and the surface ay nagiging kinetic frictional force na. Okay, so anong ginawa natin last time? So ang ginawa natin last time is in-identify natin yung forces. And na-identify na natin yung forces dito at last time it was just the normal force and the gravitational force, pero this time we have a static frictional force. So ilalagay natin yung static frictional force dyan sa ating free body diagram. And tulad din ng ginawa natin last time, we identify coordinate system. Okay, that is sort of rotated. Okay, just to minimize yung variables na kailangan nating i-solve. Okay. Along the x-axis, we can use Newton's second law. Okay, and sum all the forces along the x-axis. Okay, yung sum ng lahat ng forces na yan ay, kung titignan natin, is Fg sine theta. Okay, and then yung frictional force, which is towards the negative x-axis, so that's minus F. Okay, and along the y-axis, we have sum ng forces along the x ay y-axis, my double dot, at yan ay equal sa yung normal force minus Fg cosine theta. Okay, so oops. And along the y-axis, itong acceleration na ito ay 0. Okay, since hindi naman gumagalaw yung block hindi naman gumagalaw yung block up and down. So walang motion in that direction. Okay, which means na from the equation of motions along the y-axis, we get this relation between the normal force at saka yung weight. Okay, and we can use that to define yung ating frictional force, since yung frictional force, yung static frictional force is related to the normal force through the coefficient of static friction. So this is mu sub s mg cosine theta. Kung saan pinalitan natin yung fg ng mg. Okay. So then we plug this fs dun sa ating equation of motion along the x-axis. So we have mg sine theta minus mu sub s mg cosine theta. Okay, so mg sine theta minus, ito na yung mu sub s, mg cosine theta. Okay, at equal ngayon yan sa mx double dot. Okay, and then all the masses cancel. Itong matitira sa atin is just an expression for the acceleration. Okay, then g sine theta minus mu sub s cosine theta. Okay, the expression for the acceleration for anong tawag dito? For this block na nag-experience ng static frictional force. Of course, yung acceleration na ito, since the block is not moving, di ba? And habang inaangat mo nga yung plane na yan, hindi siya gumagalaw, di ba? And titignan mo yung gusto mo malaman kung ano yung maximum angle na hindi siya gagalaw, and pag lumagpas ka sa maximum angle na magsisimula na siya mag-slide. So, in other words, yung acceleration dito is also 0. Right? So which means na we can get E sub s is equal to sine theta over cosine theta or tangent theta. And since mu sub s is 0.4, okay, so mu sub s is equal to 0.4 is equal to tangent theta, then we can get theta to be, we can solve theta to be 22 degrees. Okay, 22 degrees. Okay, so ito yung this is how we used to do it in physics 101. Okay, so medyo straightforward pa ito. Okay, just one more example na medyo similar sa sa 101. This time lalagpasan na natin tong angle na 22 degrees. Okay? At isa-set na natin yung angle sa 30 degrees. So, since greater na to dun sa critical angle na 22 degrees, alam natin na magsa-slide na yung block. Right? And habang nagsa-slide yung block, okay, it experiences kinetic frictional force between against the surface of the inclined plane. Okay, so in this case, ano yung magiging equations of motion natin? Well, the equations of motion will still be the same. Okay, so along the x-axis, ito pa rin yung ating equation of motion. Okay, kasi wala namang nadagdag na force, di ba? And yung mga forces na yon ay hindi naman nagbago other than yung angle. So, yung nagbago lang talaga is itong angle na ito. Okay, so it's exactly the same free body diagram. Okay, and all we changed was the angle theta. Along the y-axis, ito pa rin yung equation. Yan din yung equation of motion. Okay, so along the y-axis, yung acceleration is also 0 kasi wala ka namang vertical na movement. Okay? Pero along the x-axis, gumagalaw na yung, nagsislide down na yung block. Right? So which means na meron na siyang acceleration. Which means na ito, yung x double dot ay equal to 0. Well, actually, hindi na siya 0 dun sa problem na kino-consider natin ngayon. Okay, so in this case, x double dot is no longer equal to 0. Okay, and equal to, if you recall, sa sine theta minus mu sub k cosine theta. And pinalitan natin itong mu sub k ng, yung mu sub s before dito, pinalitan natin ng, okay, mu sub k kasi dito sa problem na ito kung saan nagsa-slide na siya yung frictional force na na-experience niya is kinetic frictional force. Okay. So this is now your expression for the acceleration. Okay, and yung tinatanong dito is find the acceleration for the angle at 30 degrees. So straightforward na yan. So g times sine ng 30 degrees minus 0.3 times cosine ng 30 degrees. Okay, alam naman natin ang sine ng 30, it's 1/2, and then cosine 30 is square root of 3 over 2. And of course, g is tawag dito, 9.8. Pero if we write the solution in terms of g, so the acceleration is about 25%, di ba? 25, about 25% of the acceleration due to gravity. Okay, so mga 2.3 meters per second. Okay, so yan. So ganyan natin sinasolve yung mga ganitong klaseng ganitong problems. Okay? Okay. Any questions? Okay, I hope na parang refresher ito dun sa 101. So now, ang i-consider na natin ay itong mga tinatawag na retarding forces. Sa 101, hindi ito kinonsider. Well, pinahapyawan lang siya. Okay, may concept dun sa book. May diniscuss na concept about this dun sa book. Sa Young and Friedman, kung Young and Friedman yung ginagamit ninyo. Okay, ang idea sa retarding force is, well, if it's a projectile motion, ang retarding force na kino-consider natin dito ay air resistance, di ba? Okay. So, in other words, air resistance yung tinitignan natin. Okay, if it's air resistance, how does air resistance affect yung motion ng object? Okay, yun nga, sa 101, hindi natin to kinonsider. Even trying to solve problems with retarding forces ay hindi rin kayo binigyan ng ganong klaseng tawag dito situations, di ba? Basically, ang retarding force always act opposite in the direction of motion of the particle. And this retarding force, tawagin natin itong F sub R. Okay, F sub R or small. Pag ginamit sa book, small r. Okay, F sub R. Okay, yung retarding force na yan is actually dependent on the velocity. Okay, so velocity or instantaneous speed. Okay, so dependent siya sa instantaneous speed. Okay, speed na lang ilagay natin. Okay. Which means na habang nagbabago yung speed nung particle, nagbabago rin yung retarding force. Okay, so totally dependent yung retarding force sa speed. Okay? So we can write this tawag dito retarding force as this, as having this form. Okay, approximately negative mk v to the n, and then yung vector v over v. Okay. Okay, first of all, ano itong ano na to? So this is just a unit vector. Okay. So itong quantity na to is just a unit vector. Okay. Makikita niyo naman na unit vector siya kasi it's the velocity vector divided by the magnitude of the vector. So matitira sa kanya yung unit vector. And we didn't define it in terms of I hat, j hat, k hat. Dinefine lang natin siya in terms of the actual direction nung velocity. Okay, so this is a unit vector pointing towards the direction of the velocity. Okay? So yan yung idea dyan. O yan yung quantity na yan. And then of course, meron din tayong quantity that actually relates to the velocity. Okay, dito. Okay, yung quantity na yan is velocity to the n, speed to the n. Okay, so makikita ninyo, by the way, yung n na yan is just a number that will depend on the speed. So for example, if n is equal to 1, if the speed is between 0 and ano bang ginamit dito? 24 meters per second. So about 24 meters per second. And n equals 2 if the velocity is between 24 meters per second and the speed of sound. Okay, so about 330 meters per second. Okay, and for slow speeds, yung retarding force natin is just proportional to the first power of v. And for higher speeds, up to the speed of sound, yung retarding force natin ay proportional sa square nung speed. Okay? We also have this quantity k. Okay, ang tawag natin dito ay, well, it's just a positive constant that determines yung strength ng retarding force. So it's just a positive constant. Oops. Yeah, you can just say that yun ay constant related to the strength of the retarding force. And of course, yung m is the mass of the object. Yung m na yan is the mass of the object. Okay? So, ano nangyayari pag higher speeds? Well, we'll discuss that in a little bit. Okay? But in addition to this expression, there's another expression which is called uh, ano, actually hindi ko alam kung paano siya i-pronounce. Prandtl expression for air resistance. At yung expression na yun is W is equal to 1/2 rho times CW times A and V squared. Okay. Tapos itong CW na to is a dimensionless drag coefficient. So yung CW, so this is a drag coefficient. Okay, it's dimensionless, and yung drag coefficient na yan depends actually on the speed of the object. And yun yung nakikita nyo rito. So ito ngayon yung CW. Yan. Yan yung CW. Okay? Ano yung Mach number? Yung Mach number is just the speed of an object divided by the speed of sound, which is 330 meters per second. So pag sinabing Mach 1, ibig sabihin equal yan sa speed ng sound. Mach 2 is twice the speed of sound, and so on and so forth. Okay? So makikita nyo na from point, ano ba yan, point 7, point 8, it will start, yung drag coefficient na ito will just start to increase, magpipeak at Mach 1.5 or 1 point, ano ba yan, 1.2, something like that, and then bababa siya dahan-dahan. Okay, as the Mach number increases. Okay? Yung A na to is the surface area, di ba? So, alam naman natin na pag nagmumove ang isang object, mas mataas yung air resistance pag mas malaki yung surface area na nakaka-encounter na-encounter nung air. Right? Okay, so that's A, and then yung V of course is yung speed, and then what about itong rho na ito? Yung rho na ito is yung density ng air, okay, na ginagalawan ng object, or density ng fluid, not necessarily air. Okay, so fluid density. Okay? Okay. So, well, ang syempre ang malaking factor dito is yung drag coefficient and then yung surface area. Of course, yung speeds magdedepende yan dun sa object. Okay? And and of course yung drag coefficient also depends on the speed. So alam niyo yun, medyo complex yung nangyayari pagdating sa air resistance kung itong Prandtl expression yung gagamitin natin. Okay, and makikita natin yung effective na air resistance from these two graphs. Okay, so itong unang graph na ito is from 0 to 500 meters per second. So yung Mach 1 is somewhere here. Okay, so nandito yung Mach 1. Okay. Just for your reference. And Mach 1 is, itong letter D is just exactly the same graph. Okay, pero mas malaki yung range niya from 0 to 2,000 meters per second. So yung Mach 1 is somewhere here. And then 330 is mga 630 is Mach 2 somewhere here. Nandiyan yung 2. And 900 Mach 3 nandiyan dyan. And so on and so forth. Okay. Anong nakikita natin? For relatively low speeds, yung air resistive force is medyo malaki, di ba? Considerable. So this, may arbitrary lang na area na ginamit dito, of course. And of course, yung the air density na ginamit dito is air. Pero makikita natin na linear, more or less, yung speed below 330. Yan. Below 330. And then near the speed of sound, medyo nagiging ano na siya, parabolic, 'di ba? So yung assumption natin, yung initial assumption natin na pag n equals 1, it's linear. Okay, medyo tama. And pag n equals 2, pag malapit na sa speed of sound, it's v squared, 'di ba? So ito yung v squared natin. So medyo tama rin itong ano tawag dito, yung assumption na 'yan. And then as you go further up, okay, magiging linear na ulit siya. Almost linear. Okay, you can think of it as quite linear. So nag-i-increase yung retarding force or resistance, air resistance as a function of velocity for higher velocities. Okay? So this is just one example. Okay, yung system na tinitignan dito is this. Okay, yan yung system na tinitignan. By the way, hindi ko nabanggit. Okay. So it's a system that has that shape. Okay, and yung forces na nag-act sa kanya ay yung drag resistance, yung hindi yan weight. Yung weight is Fg. Ito yung Prandtl expression. Okay, and yung La is the lifting force. Okay, so this is a lifting force that is perpendicular, always perpendicular dun sa air resistance, okay, na W. Okay, and hindi necessarily perpendicular or aligned, perpendicular or parallel yung lifting force and yung weight respectively dun sa weight, sorry, weight, yung air resistance dun sa weight, pwede silang tilted. Okay? And then yung velocity din, the direction of the velocity follows yung direction ng air resistance. So it's opposite the direction of air resistance. So hindi siya necessarily dito sa line of symmetry. Ito yung line of symmetry ng object. Okay? And and yun nga, the reason for that is depende rin sa direction ng ano nung projectile, di ba? So kasi nagbabago yung projectile niyo, di ba? Umaakyat siyang ganyan and then nagbabago siya ng direction ng ganyan and so on and so forth. And the direction changes because yung air resistance changes as well. And the air resistance changes as a result, tawag dito, will also change yung lifting force. So, makikita nyo kung gaano ka-complex yung, ano, yung nangyayari dito. If the air resistance changes, yung lifting force changes, then yung direction din ng velocity will change. Okay, so dynamic yung ano niya, yung nangyayari. And of course, through all of these discussions, makikita rin natin na ano na, o alam natin, in-expect natin na yung total range ay mababawasan. So imbis na yung range na alam natin theoretically na medyo mahaba with air resistance, nababawasan siya ng nababawasan. And we'll see that later in an example. Okay. So let's consider itong first example sa ano with air resistance. So dito, ito na yung pinaka-simple na example na pwede nating i-consider when it comes to objects with air resistance, experiencing air resistance. So, ang pinapahanap dito, so you have this object traveling at a speed v naught, okay, and it has this displacement x. So, ang pinapahanap dito ay yung displacement and yung velocity, okay, nung object na ito. Okay, and of course, this object is experiencing a retarding force proportional to the velocity. So this means na small speeds lang itong object na ito. Okay? So anong una natin gagawin? Una natin gagawin dito is to identify the forces that are acting on the object. Okay, so ano-ano yung forces na yun? So we have this weight. Okay, mg. Okay, and we have this retarding force. Okay, at tatawagin natin yang... Okay, sige. Let's just say it's FR. Okay, so FR. And ang gamitin natin is itong expression na ito, MKV. Okay, so FR in this case ay, oops. Ito dito pala nakalagay. FR is KMV. Okay, so for consistency, tanggalin ko lang itong F na to. Yung subscript na R pala. F and mg. Okay. So F, the force is equal to K and V. Okay, so along the x-axis, so along the x-axis, okay, so we have sum of forces along the x-axis ay equal sa, okay, okay, so kailangan natin mag-drawing ng coordinate system, right? So let's say na ito yung positive y at ito yung positive x. So which means na yung resistive force ay negative. So negative K M P. Okay, and this should be equal to mx double dot. Okay, yeah, okay. And then along the y-axis, it's just the weight. So wala naman tayong kailangang i-consider dyan. Sige, sulat na lang natin for completion. Along the y-axis, okay, f sub y is equal to negative mg is equal to negative, or sorry, my double dot. Okay. So mx, so let's use this first equation of motion, yung equation along the x-axis. So ang gamitin natin. Okay, so let's begin by writing it as m. Okay. Now, tignan natin yung equation na. Nilagay natin dito x double dot. Okay. Pero dito meron tayong expression for v. So, if we want to be consistent, okay, so halimbawa dito ang pinapahanap is velocity. So, it doesn't make sense kung x yung variable na gagamitin natin. Okay, it will make sense if we use the variable v instead. So, instead of using mx double dot, I'm going to use mv dot. Okay, so mv dot. Kasi nga, the left-hand side, negative kmv, v yung ginagamit. So, ito ay negative kmv. Okay, so ganun dapat yun, ano yun, no? Yung thought process nyo when you're solving this problem and when you're trying to rationalize how to approach yung pag-solve ng problem na ito. Okay, and of course, magka-cancel yung m. Okay, and we are left with v dot. So, yan ay dv dt equals a negative k kb. Okay, and what do we do with this? So, of course, the dv dt is equal to negative k dt. And then we integrate this. Okay, ano bang typical na limits of integration dito? So, at t, initial condition, at t equals 0, we can say na yung velocity ay equals sa v naught. So, may initial velocity v naught siya. Excuse. Okay, and so anong gagawin natin dyan? So we have ln of v is equal to negative kt plus some constant. So this is an indefinite integral. Okay, and i-apply natin yung boundary condition. So ln, or initial condition, ln ng v naught is equal to minus kt, 0 yan. So is equal to plus c. So we write ln ng v is equal to minus kt plus ln ng v naught. Lipat natin yung ln ng v naught sa kabila. So we have ln ng v over v naught is equal to minus kt. Then, kunin natin yung exponential niyan. We have v over v naught is equal to exponential minus kt, or v is equal to v naught exponential minus kt. Okay, so that's pretty much straightforward. Okay. Okay, so yan yung expression natin for the velocity, and we have already solved itong part na ito dun sa problem. So next, we solve for the displacement. Okay, and to solve for the displacement, we simply use yung relation na v ay equal sa first derivative ng displacement with respect to time. Okay, so starting from this equation, v is equal to v naught exponential minus kt. Okay, hindi ko na kung ba't kumapal yan. Okay, alam ko na. Ba't siya kumapal? Okay. So starting from this expression, v is equal to v naught exponential minus kt, we know that v is just dx dt. So this is just v naught exponential minus kt. Okay, and so anong gagawin natin dito ngayon? Mag-integrate tayo, right? So dx is equal to v naught integral ng exponential minus kt dt, and we use a boundary condition. initial condition. So, initial condition natin is at t equals 0, then the initial position, let's say that the initial position is 0. Okay. So, anong makukuha natin dito ngayon? So, we have x is equal to v naught over negative k exponential minus kt, okay, plus some constant c, okay, and at t equals 0, x is equal to 0. So which means na yung constant ay equal sa, okay, so this is 0, itong t na ito is 0, which means ang constant c will just be equal to v naught over k. Okay, so ang expression natin ngayon is x equals v naught over k exponential minus kt negative, sorry, plus v naught over k, okay, or x equals v naught over k 1 minus exponential minus k. Okay? Okay. So, anong sinasabi nitong, so ito na yung pangalawang expression natin. The expression that will tell us what is happening to the displacement. Okay. For a particle that is undergoing resistive force, experiencing resistive force. So, anong sinasabi dito? So, ito yung isang equation. Okay. So, as time progresses, so as t approaches infinity, okay, yung velocity ay bumababa. Okay, which is, okay, what we expect. Okay, so, sulat ko to para maintindihan nyo yung nangyayari. Let's make sense of our solution. Okay? So, ang una nating solution, what ay velocity. So, as t approaches infinity, yung velocity approaches 0. Right? Kasi lumiliit we have an exponential minus kt term. And habang lumalaki yung velocity, habang lumalaki yung time, yung velocity nag-approach to 0. Which is of course what we expect. Di ba? Kasi nga meron na tayong retarding na force. Ang siguro hindi lang natin ina-expect is how fast the velocity decreases. Okay? So as soon as you apply a retarding force dun sa projectile ninyo, yung velocity decreases exponentially. Okay? So mabilis lang yung pag-decrease niya. What about for x? Okay? For x, as t approaches infinity, okay, yung exponential term dyan will approach 0. So, x will approach v naught over k. Okay. So, yun. X equals v naught over k. Does that make sense? Kasi yan yung magiging final na position niya. Remember that at t equals 0, nag-start siya from x equals 0, and habang nagpo-progress yung time, it should reach a final position. At yung final position niya is this. Okay, so you can determine yung final position ng isang object undergoing resistive force, a force of air resistance, simply from the coefficient k. And of course, dun sa kanyang initial na velocity. Okay, so yan yung sinasabi nung mga equations na ito. Okay, and well, of course, this interpretation makes sense. Pwede rin nating i-relate yung x sa v, yung velocity dun sa anong tawag dito dun sa position sa displacement. Okay, so anong pwede nating gawin? Anong approach natin diyan? What we can do is if we want to relate dv and dx with, or sorry, v and x, we can maybe write dv over dx. Okay? Yung relationship na yan automatically tells us na hinahanap natin yung relationship between v and x. Okay, and we can use chain rule. So we have dv dt and then dt dx. Okay, and alam natin ang dv dt is just acceleration. So we write it as is dv dt. Ganyan. And then yung dx, dt dx is just the reciprocal of 1 over v. Di ba? So now we use this. Ito, at saka ito. Okay, so I'm going to multiply this by v. So we have v dv dx equals sa dv dt. Okay? Okay lang? Nasusundan nyo pa? Now, ano yan dv dt? Ang dv dt is here. Minus kv. Okay. So we use that. Minus kv. Okay, so now we have tawag dito, this expression. Okay, first of all, i-cancel muna natin yung v. Cancel na yung v na yan. Now we have this expression that is totally, ang tawag dito, dependent on v and x. So that relates v with x. So dv is equal to minus k dx. Okay. And if we use, okay, integrate natin yan and we use the initial conditions at t equals 0, x equals 0, and at t equals 0, v is equal to v naught. Okay, so ang makukuha natin dito is v is equal to minus kx plus some constant c. So at v equals 0, x equals 0, v equals, sorry, at t equals 0, x equals 0, and v equals v naught. Okay, so at t equals 0, x equals 0, v is equal to v naught. Which means na v is equal to, or yung ci equals a v naught. Okay, so v is equal to v naught minus kx. Okay, so yan na ngayon yung relationship between v and v naught. Okay, nagme-make sense ba tong solution na ito? Let's check. Okay, let's take a look here. So, as t approaches infinity, yung v approaches 0. So, itong term na ito will be 0 at t equals infinity. Okay, which means na ang x will simply be equal to v naught over k, which is, oops, which is what we have here. Okay? Okay, so, yung equation na ito na na-derive natin that relates v with k is tawag dito consistent with everything that we've solved so far. Okay? Okay, so yan ang pinaka-simpleng system na nag-undergo ng air resistance. Any questions? Any questions? Meron ba kayong gustong balikan? Masyado bang mabilis or ano, tawag dito? Or nasundan niyo naman yung yung discussions? Okay lang? Okay. Okay. Now, ito yung next simple problem. Anong dinagdag natin dito? Ang dinagdag natin dito ay gravitational force. So ngayon, yung projectile ay nagmo-move along the vertical axis. Okay, and dahil nagmo-move siya along the vertical axis, it experiences the gravitational force, the resistive force is collinear with the gravitational force. Okay? So, kanina perpendicular yung gravity at saka yung resistive force. Pero ngayon, collinear sila. Parallel sila sa isa't isa. Okay. So, how do we approach this problem? So, of course, ang gagawin pa rin natin is to draw a free body diagram. Diba? And free body diagram natin is, well, ito na yung gravitational force. Gravitational force is downward and yung resistive force is upward. Okay, so mg. And then, dito naman na yung coordinate system. Dito ang coordinate system is that z, positive z is upward. Okay, dito z yung ginamit, hindi y. Okay. So, ano nang mangyayari dito ngayon? Along the z-axis lang yung i-consider natin. So, along the z-axis. Okay, so along the z-axis, yung sum ng forces ay equal sa minus g, okay, which is pointing downward. Okay, and kmv. Okay, now ano yung sign nung kmv? Now you might be tempted to, ang tawag dito, to say na yung kmv, tawag dito ay pointing, since it's pointing upward, lalagay nyo dyan plus sign. You can do that, actually. But remember na yung velocity is opposite in direction dun sa anong tawag dito? Dun sa movement nung projectile. Saan papunta yung projectile? Okay, pababa. Di ba? So, sorry. Yung hindi. Ulitin ko. So, F is kmv. Okay, so yan. kmv. And then unit vector. Okay. Ang direction ng F is opposite in direction sa motion ng object. So, habang nalalaglag siya, yung F ay paakyat. Pero remember na yung kmv na yan is, anong tawag dito, yung velocity na yan ay pababa. Di ba? Ang direction ng velocity niya pababa. Yan, nalalaglag siya. So, pababa siya. So, what we can do is, we can write here a negative sign to indicate na yung velocity is pointing downwards. At na yung velocity is opposite in direction dun sa resistive force. Now, you can, tawag dito, it's actually easier to solve pag yan ay negative sign. You can write a solution na kung saan yan ay positive, positive kmv instead. Okay, but ano tawag dito, yung interpretation will be slightly different. Okay? So, ang idea lang dito is that the velocity is downward. Okay, mathematically, ang ibig sabihin nun, ang velocity is negative. Di ba? So that minus kmv is actually positive. Okay? Velocity is negative. And since this is negative, yung resistive force na minus kmv, okay, is positive. Okay, kaya positive yung, kaya naka-point pa rin siya upward. Okay, so kaya negative sign yan, para naka-point upward yung resistive force. Okay, so ito lang yung tatandaan nyo, pag nag-i-interpret na kayo, ito yung tatandaan nyo lang, na sinet natin na yung velocity ay negative. Okay. So now we have this equation. Of course, pwede na, napansin natin na in terms of velocity yung ating expression, di ba? In terms of velocity yan. So we use dv dt, not dx squared dx dt squared. Okay. Okay, so dv dt. Okay, so now we have this differential equation dv dt is equal to minus mg oh, mg plus k mv. Okay. Okay, and then how do we solve this? dv over mg plus kmv is equal to negative dt. Wait, sabi ko na nga ba may nakalimutan ako. May m kasi dapat dyan. May m dito at makakancel lahat ng m. Okay. So, g plus kp. Yan. Okay, now, tawag dito, we integrate, di ba? Siyempre, ang ginagawa natin dito, di ba? Ginagamit natin yung let u method, di ba? Let u be equal to g plus kv, so du is equal to k dv, di ba? So, yung expression na yan ay pwede natin isulat as du over k all over u, okay? Or 1 over k du over u is equal to minus dt. So, du over u is equal to minus k dt. So, ln ng u is equal to minus k t plus some constant. Okay, anong magandang boundary conditions dito? We use the same, initial conditions. We use the same initial condition na at t equals 0, ang v has its initial velocity v naught. Okay, and so okay, palitan natin ito ng ln ng g plus kv is equal to minus kt plus c. So at t equals 0, v is equal to v naught. So c ay equal sa ln ng g plus k v naught. Okay. Mm, mm, mm. Sandali. Mas magiging okay, sige, tignan natin kung saan ito pupunta. ln ng g plus kv. So we have g plus kv over g plus kv naught. ln ng g plus kv is equal to minus kv plus ln ng g plus kv naught. Okay, so of course minus yun. So ln ng g plus kv over g plus kv naught is equal to minus kt. Okay, and then we, oops, is Sige, iiwan lang natin yun dyan. So, G plus KV over G plus KV naught exponential minus KT. Okay, and G plus KV is equal to G plus KV naught exponential minus KT. Okay, and gusto natin i-isolate yung V. Okay, so first of all, ilipat muna natin yung G sa kabila. Okay, so, and then divide by K. So, KV is equal to G exponential minus KT minus G plus KV naught exponential minus KT. Okay, and wala akong ginawa dyan, kundi ilipat lang yung G sa kabila. Then divide everything by V. So, G over K, divide everything by K, sorry. Times exponential minus KT minus 1 plus V naught exponential minus T. Okay? So yan yung expression natin ngayon for the velocity. Siyempre, kung halimbawa kayo yung nagsisolve ng problem, ano? Ngayon ko lang nabasa yung comment mo, ano, Elfritz. Okay. Na-figure out ko din. Salamat sa comment. Okay, so, syempre gusto niyo alamin kung nagme-make sense yan. First, i-test niyo muna yung boundary, yung initial conditions, di ba? T equals 0, dapat ang V naught, dapat mag-approach sa V yung V naught. Okay, so, pag T equals 0, um, pag T equals 0, ito ay 1. So, 1 minus 1 is 0. So, itong term na to 0. And pag T equals 0, ito ay 1. So, V is equal to V naught. Okay, so may sense. Okay, and so tama mathematically. Okay, or mathematically consistent yung ginagawa natin dito. Okay, and what else? Ano pa yung isang evidence na ano na ang tawag dito? Na somewhat reasonable itong solution na ito. Well, before nung hindi natin nung perpendicular yung um, weight dun sa resistive force, ang solution lang natin was this, di ba? Okay, ang solution lang natin was V naught exponential minus KT. Okay, pero nung ginawa natin silang collinear or parallel, nagkaroon tayo ng additional term given by this. Okay? And that additional term arose dahil nga finactor in na natin yung gravity. Okay, kung papansinin niyo walang gravitational term dito, walang G dito. Yung G nandito sa ano na to, sa expression na ito. Okay? So, this expression ang tawag dito, does indeed make sense. And if you graph this expression for different values of the initial velocities, you will actually end up with this, with figure 2.6. So yung figure na nandito. Okay? So yung figure na nandiyan. It turns out na, of course, if V naught is equal to 0, ito yung graph na makukuha ninyo. Yan. Okay? And as you increase V naught, okay, as you increase V naught, ang makukuha niyong graph is this, di ba? So it still has this exponential na dependence. Okay, then lalagpasan niyo yang or aabot kayo diyan sa G over K na yan. Okay. Ano ang tawag natin diyan sa G over K? Okay, ang tawag natin diyan actually, remember, kung titignan niyo rito, G over K is a coefficient of this term, which means na ang units nitong G over K is units of velocity. Okay, so this means na ang G over K uh, is interpreted as some type of velocity. And in fact, itong velocity na to ay tinatawag natin na terminal velocity. Okay, terminal velocity happens when the resistive force, okay, you get terminal velocity when the resistive force is exactly equal to the weight. Okay? So, pag yan ang nangyari, then you reach terminal velocity. Sa for tawag dito um sa Physics 131 and siguro sa 101 din yung diniscuss nyo. Sa Physics 131, isa sa mga problems na pinasolve sa inyo is yung ano, 'di ba, yung pinagpipilian ninyo nun is yung parachutist, 'di ba? Pero walang kumuha sa inyo ng parachutist eh. Kasi siguro mababa yung points, no? Well, ang idea dun is magsa-start from, 'di ba, pag tumalon yung parachute off the plane, dahan-dahan siyang bababa, right? Dahan-dahan mag-i-increase yung speed niya. Okay? At the same time, nag-i-increase din yung kanyang resistive force. So habang nalalaglag siya, bumibilis yung kanyang speed, nag-i-increase din yung resistive force. Okay? Until such time na yung resistive force ay magiging equal na sa gravitational force, sa kanyang weight. Okay? And when at that time na mangyayari yun, magre-reach na siya dun sa tinatawag na terminal velocity. And anong implication sa parachutist? Ang implication nun is once it reaches terminal velocity, hindi na mag-increase yung kanyang velocity. Kasi hindi na mag-increase yung ano eh, yung anong tawag dito, yung resistive force. Kaya nga siya tinawag terminal velocity kasi it's the final velocity of that particle. Wala, yung net force is zero, di ba? Yung net force is zero. So there's no longer an external force that causes that object, that causes the parachutist to accelerate. So kung hindi na siya nag-accelerate, hindi na rin magbabago yung velocity niya. Okay, so ang nangyayari sa parachutist is mag-increase yung velocity, mag-increase yung velocity niya hanggang sa terminal velocity, and then at terminal velocity, wala na siyang net force, so constant na lang yung kanyang velocity. Constant na lang yung kanyang acceleration. Zero yung acceleration niya actually. Okay, so yun yung ibig sabihin ng terminal velocity dito. Okay, now okay, so ito yung equations of motion natin. Okay. Now, moving forward, if V naught, okay, is actually greater than the terminal speed, okay, ito naman yung makukuha nating graph. Okay, para sa isang projectile. Okay. Okay. Any questions so far? Okay. Gusto ko lang na maintindihan nyo ng konti kung ano nangyayari dito. We're talking about the initial speed dito. Di ba sinabi ko kanina na anong tawag dito? Na, na about the parachutist, it started from an initial velocity of zero. And for the case of the parachutist, ito yung graph na sinusundan niya. Yung time, at some time, aabot siya sa kanyang terminal velocity. But if it so happens na yung object ninyo did not start at an initial velocity of zero, at yung initial velocity niya is below the terminal velocity, then you get this behavior. Pero kung yung object, okay, ay merong initial velocity na greater than the terminal velocity, okay, ito yung susundan niyang behavior. Okay, exponential. But regardless, after a certain time, aabot na rin siya sa kanyang, anong tawag dito? Terminal velocity. Okay, so yan yung interpretation natin for this, for the velocity. Okay, that's actually just one part of what we wanted to solve, velocity of a particle. The second part is the displacement. Okay, so paano natin isosolve yung displacement dito? Now, of course, V is equal to dz dt. Remember, z yung ginagamit natin na axis dito, hindi hindi y. Okay, and this is straightforward naman na isolve kasi wala naman tayong z na variable dito. Okay, so this is just exponential or g over k. G over k exponential minus kt minus 1 plus v naught exponential minus kt. Okay, so z, hindi ko na gagawin yung mathematics. Uh, h minus gt over k plus k v naught plus g over k squared 1 minus exponential minus k. Okay, kung saan yung boundary conditions niya. Initial conditions niya is at t equals 0, yung z is equal to h. Okay? So, in other words, nag-start siya dito. So, z is equal to h at t equals 0. So, ito yung t equals 0 na position. Okay, and then nalalaglag siya. Okay? Okay. So, yun yung pangalawang expression. Okay? And makikita naman natin na ano, 0 siya talaga at z is equal to h talaga at t equals 0. Kasi if this is 0 and this is 0. Pag 0 ito, wala na tong term na ito. And pag 0 ito, 1 minus 1 will be 0. So, ang matitira na lang is z equals h. Also, what do we expect? Anong klaseng behavior ang ma-expect natin dito? We have 1 minus exponential kt. Anong graph ng 1 minus exponential kt? So, ito ang exponential, di ba? At ito naman yung 1 minus exponential. Right? And then may t tayo dito, linear na term ng t. So, ang linear na term of course is pag ganyan. And then, i-add mo lang yung linear na term dun sa 1 minus exponential. So, you would expect na magkakaroon, meron pa rin, doon pa rin yung 1 minus exponential na term kasi dominant naman talaga ang exponential. So, mag-shift lang siya actually upward. Okay, i-shift siya upward na ganyan. Okay, kasi tumataas ito eh. Tumataas yung value niya, so tumataas din dapat yung, diba? Ina-add nyo dapat yung exponential dun sa linya. Okay, so, nagiging ganyan yung kanyang graph. Okay, so yan yung ina-expect natin na behavior nung z. Oops, sorry, mali ang aking interpretation. Dapat mag-approach siya sa h, di ba? Ulitin natin. Ito yung axis. Ito yung exponential negative kt. Ito yung 1 minus exponential kt. Okay, and yung linear na term is actually negative. May negative sign doon. Yan ang hindi ko nakita kanina. So actually, negative siya. So pababa siyang ganyan. Oops. So pababa. Okay. So dapat sinusubtract ko yung result. Okay. So ano magiging result niyan? So dapat magiging ganyan siya. Okay. Okay. And this will be z is equal to h. Okay. So at t, for large values of t, Hindi. This is z equals h. Yeah. Kasi ang initial position nga niya is z equals h. Okay. And ito, mag-i-increase lang yan continuously. And for large times, magiging linear na lang tong behavior na ito for large t. Okay, bakit? Kasi magiging dominant na tong term na ito. Okay, ito kasi may 1 minus exponential term ka. So for large t, linear na siya. Okay, and it will just, anong tawag dito? Approach infinity, towards infinity. Okay, so yan yung interpretation natin for that. Okay, any questions? Okay, so lahat ng mga ito ay nasa book naman. Okay. Um, okay. Gusto ko rin i-discuss sana tong problem na ito. So we'll find time to discuss this next meeting kasi this problem sort of involves a unique solution para makuha yung trajectory tsaka yung velocity. Okay. Of course, we can use numerical solution and ipapakita rin naman natin yung next meeting. But there's also, anong tawag dito? Well, eventually makakuha tayo ng tinatawag na transcendental equation. Okay, and yun sana yung gusto kong ipakita sa inyo kung paano isolve yung mga ganong klaseng equations. Okay, para in the future alam niyo kung anong pwede niyong gawin. Okay? So we'll stop here. We'll stop with this, okay, with these two examples, and then continue with this example next meeting. And from this example, pagpatuloy na natin yung discussion sa conservation theorem. Okay. Any questions? Any questions? Okay, stop share. Okay, kung wala ng question, then I'll see you next Tuesday by Zoom ulit. Thank you.